Hello everyone, hopefully you are able to see the screen. Could someone confirm that you can? Okay, thank you, Ahmet. So today we are going to start discussing about relational schemas because it is going to be our way into creating tables. So, by the way, I already sent you an email about that before, but for any of the lab recordings, they are on this website about the lab materials, and we also have the slides for this lab as well here. And as I prepare this material, it will be posted on this website.
Before we start, can I ask a question?
Yes, sure.
Do you know anything about the quiz dates or format?
No, unfortunately. So the teacher decides about the quizzes. So I'm not aware of anything.
Okay, so it won't be in the lab sessions, right?
No. During the labs we have the tutorials and quizzes will be during lecture only.
Okay, thank you.
Okay. Any other questions, problems? You can interrupt me and ask at any time. So today we are going to start discussing relational schema, and you also see such things during the lecture, but this is going to be some kind of reminder, and also we also need some way of to formalize how we write the relational schema. And you are able to describe your storage requirements with an ER diagram, and the relational schema is going to be an equivalent representation of that. In the relational schema, we can give more detail about our tables. In the ER diagram, we have entity sets, relationships, different kinds of relationships, in fact. But in the relational schema, everything will be converted to a table. And according to the setting of that table, this is going to be decided mostly based on the foreign keys. We can represent entity sets or relationships. Basically, anything that we have a foreign key in it could be a relationship in the ER diagram. In the relational schema, we can give more detail about the types of the attributes. Basically, we are going to write the name of that table. For example, in the entity set or in the relationship, this is what's written inside the shape. This is going to be the name of the table. We list our attributes, but this time we can also give the type information. So whether it's a numeric, text, date, or Boolean type, we can define this, and these are something we decide according to the description of the database. For example, for names it can be text, but for an ID it could be numeric or text, etc. We also have this not null keyword to say that without entering this attribute we cannot insert a new entry for this table. So to be able to insert any entry into this table, this column, this attribute should be filled. That's how we define not null. And for some attributes other than the primary key, we might have unique constraints as well. With this unique constraint, we will see it more detail in a minute, but we are going to use it mostly to design cardinality, because cardinality is about how many of the attribute or how many of the entities could match with how many of the other entity. For example, with a relationship, we talked about the cardinality, and to design cardinality in a table, we are going to use this unique constraints. But for the primary key is already unique, and for the primary key, we don't need to specify that it's unique. We write our primary key attributes in the table. We can have a composite primary key, then we are going to list more than one attribute next to this primary key line. We also can have foreign keys in our table. In that case, we are going to write the foreign key attribute, and then we also need some other table that we need to reference. So foreign key is used in relationships and also in the child entities with an is a relationship we have the parent and child entities. Inside the child entity, we are going to keep a foreign key that is going to reference the parent's primary key. So the foreign key could be one or more attributes, and it's going to reference some matching attributes in a different table. So this matching part is kind of important. So if attribute 1 is numeric, for example, the attribute X that we are referring to should have the same type as well. They should be compatible with them. So we are going to see each of the ER diagram elements and how we can turn them into relational schema. And basically these relational schemas are going to help us while creating the tables, because in the SQL database we are going to create tables. For tables we don't have the distinction of entity sets, relationships, etc. by itself. We design the table so that it refers to that ER diagram. And for entity sets it is trivial. We just have the table, we list all the attributes, and we can have one or more attributes as the primary key of this entity set. In that case, we write next to the primary key those attributes, for example. And for primary keys, having the not null option is mostly a good idea, because without the primary key we don't have a way to find or select unique rows of this data. So when we start populating this table, it is going to be similar to an Excel sheet, and while you are searching for a line, that should have some primary key, and if you allow null values for the primary key, that makes the life harder. So usually we keep the primary keys as not null, and if some value is also required in the logical way, so we have a description for the database, for example, and to log into this database, let's say we are using the user's ID and the password, and without a password the user will not be able to log into this database, let's say. In such cases, some other attributes could be specified as not null as well. So everything, all attributes could be not null if you decides, for example. So in is a relationship, we have the parent and the children of that entity set, and what we basically mean was inheritance. So the child entities were inheriting the attributes of the parent, and it was also inheriting the relationship capabilities. For example, if the user is in some relation with some other entity set, then the child entities could participate in the same relationship as well. While we go into the tables, in the child entities, we keep foreign keys that reference the primary key of the parent. So for example, I have the teacher and student child entities, and for the table of the teacher, I need some foreign key that is going to reference the primary key, which is the ID of the user, the parent entity set. And the name of that attribute inside the teacher table is not that important. What's important is that any attribute that I store in the teacher table is going to refer to the ID of the user. So we decided to have TID in the teacher. It could have been ID as well, but to distinguish the names, for example, for users we have IDs, and for teachers we have TIDs, for students we have SIDs. So having different names could help us to remember which kind of user is this. Again, this is going to be the primary key of this teacher table, because there is only one attribute in the teacher table, and for every table we need to have some primary key. Whether it's a child entity set, whether it's a relationship, we need to have a primary key, some primary key for all the tables. So since we just have one attribute in the teacher table, it is going to be the primary key as well. And this foreign key will help us while inserting a teacher's TID. For example, let's say I would like to make the user with ID, I would like to assign that user as a teacher. Then, while I'm trying to write the value 5 for teacher's TID, it will check whether a corresponding entry in the user table exists or not. So it will first check if there is a user with ID 5, then it will allow me to enter 5 into here. If there is no user with ID number 5, then it will not allow me to enter or assign 5 as the teacher. So the foreign keys will actually help us to maintain the database. So for example, if I allow that there could be the ID 5 in the teacher table, and if that ID is not corresponding to any user, then this doesn't make sense in our database. So with foreign keys, we make sure that while inserting some entry to some table, the related entry in a different table would also exist. In the student case, it's the same thing. We just have this additional attribute called scholarship. So in the ER diagram, we were showing this additional attribute. In the ER diagram, for the child entity sets, since we were inheriting the attributes of the parent, we are not showing the primary key of these child entities explicitly. The primary key of the child entities is the foreign key in this table. So for example, for the teacher, our foreign key is TID, and that's also the primary key. So for child entities, the foreign key becomes the primary key. So this is some other example. In some cases, the parent can have multiple attributes as its primary key. For example, in this example for device, we have the model and brand, and model name and brand number together define a unique row for the device table. We also have this price attribute, so the relational schema for devices here. Then for the child entities, in order to find the related or corresponding device, for example, we have faulty devices and second-hand devices. For a faulty device, in order to find the corresponding entry in the device table, I need both the brand and model, because the primary key of device is both model and brand attributes. So in the child entity, I need to keep individual attributes that are going to reference the corresponding attributes in the device table, in the parent table. So for the second-hand table, I keep SH brand, so the naming is not that important, but to know that it belongs to a second-hand type of device, we called it SH brand. It could have been brand and model as well. But these two are going to be foreign keys together. So SH brand and SH model together is going to refer to a device through this primary key, brand and model. So this SH brand should have matching type with this brand, and SH model should have matching type with the model in device table. So for second-hand devices, we keep the condition and contact information. For example, these are our additional attributes. Some of them could have not null option as well. So this is something we decide according to the description, but for the primary key, by default, we should write that they are not null, and the primary key, the composite primary key, is by default unique. So we don't need to specify whether these are unique or not. By this primary key assignment, it's already unique, and for shorthand for primary key, we can use PK, and for foreign key, we can write FK. And similarly for the faulty table, it's the same thing, we just have different additional attributes. Then given, yes, sure.
Yeah, my question is, after we are writing the foreign keys, can we just write devices, or should we write random model in parentheses too?
So the thing is, the naming convention is something we decide, right? So for these foreign key names, we could have give any of the different names. So we should specify what is going to match with which attribute. So in the device table, we have this brand and model attributes, and like in order these should match. So actually, like we need to write, because otherwise there could be like many attributes in the device table. I guess you are saying because they are the primary key, they should match. So that's actually correct, but while we are creating the tables, actually we can refer to some attributes that are not the primary key. So then it could become confusing. So because of this ER diagram, we are actually referring to the primary keys, but while creating the tables, it allows to match any of the attributes with like any of the other attributes. So it could become confusing that way.
Okay, thank you.
No problem. So then we have relationships. And in the relationships, we need a foreign key to each of the connected tables. In the ER diagram, we are showing these with lines. So a relationship is connected to multiple things. They could be like entity sets, or we may be using aggregate relationship. In that case, we are connected to a dashed rectangle. These lines that are linking the relationship into something else are meaning that we need to have a foreign key in this table that is going to refer to that other table's primary key. And again, we should have matching types for these foreign keys with the related primary keys. And to determine cardinality, we are going to decide how to assign the primary key of the relationship. So for the entity sets, the primary key is already written in the ER diagram. For the child entities, it is going to inherit from the parent entity. Again, it's kind of decided. But for the relationships, the cardinality is going to decide how we assign the primary key. So starting with the many-to-many relationships. So let's say in this case we have this example. Members are in groups, and in a group there could be many members, and a member could be in many groups. So this is a many-to-many relationship. For member, we have this member no and member name attributes. Member no is the primary key, and for the group entity, we have this group number as the primary key, and we also keep the group name. If we look at the tables, for example, for members and groups, while matching members to groups, we are going to use the table in. So for this relationship, we are going to store a table, and inside this table, we can, for example, match user or member number 1 with group number 1, and member number 1 could also match with group number 2, since this is a many-to-many relationship. And similarly, for group number 3, for example, it can match with different members. So for the primary key of this table, we need to have the composite of these two foreign keys. So member no and group no together should be the primary key, because otherwise, if we just look at the individual columns, for member number we have duplicate values, and for group number as well we have duplicate values. So the primary key should be something that has no duplicate values in that table. And for many-to-many relationship, it is the combination of all its foreign keys. So if this was a ternary relationship, in that case, if it was many-to-many, then it is going to be again the combination of all its foreign keys. So in the many-to-many case, when we are writing the tables, relational schema for it, for member, this is the setting, for group, this is the setting. They have their primary keys, their entities, the primary key is already given. And for this relationship called in, we also need a table. And in that table, because of these connections, I need to store some foreign key that is going to reference the primary key of the member table. And because of this other link, I also need some other foreign key that is going to reference the primary key of this table. So I have two foreign keys, member no and group no. In this case, we use the same names. It could have been different names as well. But the important thing is that the member no attribute is going to refer to the member no attribute in the member table, and the group no attribute is going to refer to the group no attribute, the corresponding primary key of the related table group. And for the primary key of this table, it is going to be the combination of its all foreign keys, because this is a many-to-many relationship. With relationships, we also have one-to-many setting, and in the one-to-many case, the primary key is going to be the one that does not repeat. So among the foreign keys, in a one-to-many relationship, one of them is going to not repeat it well. One of them is not going to have repeated values. For example, if owner has dogs, and if this is a one-to-many relationship, meaning that one owner can have many dogs, but for a given dog, that dog is going to have just one owner. If we look at the table, then we are matching the owner's ID with dog's ID, and for a given owner there could be multiple dogs matching. For some of them, maybe for owner 1 there is only one dog. For some of the dogs there could be no owners, but what we know from this one-to-many setting is that if I have the dog's ID, that dog's ID is going to have it is going to be a non-repeating value in this table. So dog ID column in this table has non-repeating values. So both of these are my foreign keys, but my primary key for this table is dog ID only, because given a dog's ID, I can already know who is the owner. But if I have the owner's ID, then I could have multiple matching dogs, so I'm not able to find a unique row here. And if we look at the corresponding relational schema, for dog and owner we have like similar cases. The entity sets tables are kind of trivial, and for this relationship called has, this should be actually named as has, we need to keep foreign keys to both of these tables, and the primary key is going to be the one that does not repeat. So for this relationship, the dog ID has all unique values, it doesn't repeat, so therefore we assign dog ID as the primary key of this table, but we need to specify both foreign keys. So foreign key concept is something different than how we assign the primary keys in a relationship. There is also one alternative. So you might say that, okay, if I just look at this table, knowing just dog ID, I can find a unique row, but let's say I can also use dog ID and owner ID together. So if I use these two columns together, then again I can find unique rows. In this case, what we need to do is, while assigning dog ID and owner ID as a composite primary key, we also need to specify that dog ID is going to be unique. Because the primary key, if we have a composite primary key, as a tuple, together they are going to be unique. These two are going to be unique as a tuple, but for one-to-many relationship to exist, the dog ID by itself should contain unique values. So in this alternative case, we need to also say that dog ID is unique to satisfy the one-to-many condition if we decide to assign the primary key as both dog ID and owner ID together. But this previous option was better because we are solving the case with like less number of parameters. So to find a unique row, just one column is going to be enough in this case. Otherwise, we need to know both columns, and then we need to specify that dog ID is unique by itself. But in terms of the usage, these two are going to like satisfy the same condition. And then we have the one-to-one relationships. In one-to-one relationships, for example, let's say we say passwords belong to people. One password can belong to only one person, and one person can have only one password, let's say in this case. And in this case, both of these columns, both of these foreign keys in the relationships table are non-repeating. Then this time we are going to choose one of them. So it could be the passport ID or it could be the SSN of the related person, but we need to choose one of them. And for the other one, we need to say that this should have non-repeating values. So we are going to have two alternatives, and in this case they are going to be equivalent. So for passport and person, we have specified the tables. For person, we have SSN as the primary key. Therefore, we need to keep some foreign key in the belongs to table, and this SSN foreign key is going to reference the SSN in person table. And similarly for the passport ID, we are going to reference the passport ID in the passport table. And we can say that, okay, primary key for this table is SSN, and for the other foreign key for passport ID, it should contain unique values. It should not have repeated values. So this is one alternative. And the other one is we can say, okay, password ID is going to be the primary key, and then SSN should contain only unique values. And in this case, both alternatives are equivalent. You might choose one or the other. And sometimes according to the description of the attributes, one might make more sense. For example, in this case, maybe SSN option is the better one, because let's say for all our users we are already using the SSN, but in terms of the database they are like equivalent. Sometimes the relationship could be connected to the same entity set, to the same table multiple times. So in the ER diagram description from lab number 1, we had such case. And like we discussed this before, for sending messages, the message could be an entity set itself. But for the sake of giving an example, we decided that message can be an attribute and date could be the part of the primary key for this relationship. Because in the description it was saying that on the same date, one particular sender can send to a particular receiver only one message. It was saying this in the description. Then we decided this ER diagram could also satisfy that condition. And in such case, if we have multiple links to the same entity, to the same table, we need to keep multiple foreign keys in the relationship. For example, for this relationship called send, I'm going to have a sender ID and a receiver ID. And sender ID is going to refer to a user's ID, and receiver ID is going to also refer to a user's ID. So for a user, ID is the primary key, and these foreign keys are or let me say it like that, these two foreign keys could refer to different users, and in fact most of the time they are going to refer to different users, because it doesn't make much sense to send a message to yourself. Sometimes you do, but let's say most of the time senders are going to send messages to different receivers. Since we define these foreign keys on different lines, they don't have to contain matching values. So this is something different than low. So let me go back a little. So in this case, we had the device parent and the second hand and faulty as the child entities. In this case, since the primary key is a composite one, multiple foreign keys together were referring to this primary key. So together they could refer to some primary key, but in this case these are separate foreign keys, so they are referring to the same table, but they can refer to different entries in that table. Therefore we can, like, let's say Ali is the sender and Ayşe is the receiver, and to distinguish Ali sending a message to Ayşe, we also make the date a part of the primary key. So if this was just a relationship, since it's many-to-many, we were going to say that, okay, primary key is the sender ID and receiver ID together. But in the ER diagram, since the date is also marked as a part of the primary key for this relationship, we also included date. And since it is a part of the primary key, we said not null for sender ID, receiver ID, and date together, so that they form the primary key of this table. And like date has date type of data, and sender ID and receiver ID has numeric data. So for relationships, we can also talk about participation. And we cannot enforce total participation for every relationship. So there needs to be some conditions satisfied so that we can enforce total participation on the database side, on the design side. For any type of total participation, we can also enforce it in the application side. So right now we are going to design the relational schema, then we are going to create the tables. And according to the design of the tables, for some total participation constraints, we can enforce that. But for some of them, for the many-to-many kind of relationships, we cannot enforce total participation while creating the tables. Then in such cases, we can leave the work to the later stages. In the later stages, for example, in the application side, while creating a user, you can say that, okay, you need to also choose this. So we are going to actually have a more concrete example of that. But for the one-to-many and one-to-one relationships, if the total participation is on the non-repeating side, we can merge these two tables to enforce total participation while creating the tables in the design of this relational schema. So let's say in this case, we have teachers, advisors of the students. So this is a one-to-many relationship, meaning that a teacher can be the advisor of multiple students, but for a student, there could be only one teacher as their advisor. So this is the one-to-many part. And because of the total participation, so because of this bold line on the student side, we are saying that every existing student should also participate in this advisor relationship. For every student, there should be an advisor. Or we can also say it like that, there shouldn't be any student whose advisor is not some like assigned teacher here. So in this case, we could write the tables, the relational schema like that without the total participation. So remember in our previous slides, we said that for a teacher, TID is the foreign key. For a student, SID is the foreign key. These are just this information repeated in the slide as well. We need the advisor table, and since this is a one-to-many relationship, the non-repeating side is the student, so primary key of this table could be SID, and then SID and TID are foreign keys to the respective tables. But this doesn't enforce total participation. To enforce total participation, what we can do is to merge the relationships table with the table that has non-repeating values in the relationship. So student's ID has non-repeating values in this relationship. So while merging, we can say that, okay, since I already know that for every student there should be an advisor, let's keep that advisor's TID inside the student. So while creating a student, so I assign one of the users as the student, writing its that student's SID, and if there's scholarship amount, I also write that. And for this student, since I need to have an advisor, I'm going to also write the advisor's TID. In this case, for student table, the primary key does not change because SID was enough to find a unique student. But then, so this SID foreign key is because student is a child entity of the user table. But then we also store this advisor TID, and this advisor TID should correspond to an existing teacher's TID. So with this foreign key, we are making sure that whenever I assign some teacher's ID as the advisor of the student, that teacher's ID should exist in the teacher table first. So we did not do any changes for the teacher table, but we merged the student table with the advisor table. So in the ER diagram, I have two separate elements, but in the relational schema, one table could refer or could include two different things or multiple elements of the ER diagram. You might change the naming, so you can say, okay, this is now a student with advisor to like give more information. But again, you can just keep the naming as student as well. So both are okay. Actually, having long names is going to tire you because keeping the names short is like actually a better idea. But for the sake of example, we are going to use this naming throughout this example. So the changing name is optional, but what's important is that for this total participation, for this merging to happen, this should be a one-to-many relationship, or in the one-to-one case as well, we can merge the tables. if the total participation is on the side that has non-repeating values in the relationship. So what if the total participation on the other side? So let's say in this case every teacher should be the advisor of at least one student. So if there is a teacher, that teacher should participate in the advisor relationship at least once. In this case, we don't have total participation on the student side. But we cannot do it by merging the tables. We cannot enforce this throughout the design of our tables. For such cases, you can enforce it in the application. So why we cannot merge? Because for a teacher there could be multiple students to advise, and in the teacher's entry, for example, I have an Excel sheet for a teacher's line, for a teacher's row. I cannot write all the different students on that same row. I need to have a fixed column or fixed number of attributes for any of my tables. Therefore, I cannot just append the student's ID into one single field. So that's why we are not able to merge these two tables. Therefore, if we need to enforce total participation, that's going to be on the application side. While creating a new teacher, you are going to say that, okay, this teacher should advise at least one student. First choose that student and then I can create a new teacher, for example. That's like enforcing it in the application using Python. So for relationships, it's a good idea to reduce the number of tables if you are able to match the relationship. So in the one-to-one and one-to-many settings, if there is total participation on the non-repeating side, it's the better idea to enforce this total participation while designing the tables. So for any kind of total participation, you can leave it to the application side, but if it is applicable, it is a better idea to do it while designing the tables. So these are again showing some parts from the ER diagram from lab number 1, and we had like teachers are giving courses, and for a course there could be only one teacher, but a teacher can give more courses. So this is according to the description we had. Maybe that's not a realistic scenario. Maybe a course could be given by different teachers, etc. But in this description, that was the ER diagram that we decided. For this one as well, instead of having a separate gives table and a separate course table, we decided to merge these two tables together because of this one-to-many setting and there's total participation on the course side. So this time we did not change the naming. For a course, we write the course code, the description, these are the attributes, and the primary key of this table was the course code by itself. But we are storing a foreign key called instructor ID, and this instructor TID is going to refer to an existing teacher. So for the course relationship, so for the gives relationship and course entity set, we decided to merge these tables together. Let's also discuss the weak entity set and weak relationships. So weak entities can actually appear in a fixed scenario. So in this fixed scenario, we have this strong entity side, and the weak entity is going to be connected through a weak relationship. And that weak relationship, by the definition of the weak entities, it is going to be one-to-many with total participation on the weak side. So this is actually the same scenario that we merged the tables. So while creating the relational schema for a weak entity, we are going to merge the two tables together. One difference is that for this merged part, we also need to use the foreign key as part of the primary key. So in this case, for student, we had SID as the primary key. So for medical reports, the partial key is date. So to be able to find a unique entry, I need both the date and the corresponding student's SID. So therefore, when we merge these two tables together, we have the date and description attributes. SID is the foreign key. So SID is a foreign key that refers to the student with advisor table. Remember, we had changed the naming, therefore this is going to be not the student table but the student with advisor table. In there I have the primary key as SID. And for this new table called has medical reports, the primary key is the combination of date and SID. So I need both of these information. So while merging these other tables that are not weak, the foreign key was not affecting the primary key. And for the weak entities, the foreign key also becomes a part of the primary key. So that's the difference. And then we have aggregate relationships. And in the aggregate relationships, actually, the difference is that instead of connecting the relationship to an entity set directly, we are connecting a relationship to an existing relationship. And in the ER diagram, so as not to have confusion, this has some special notation. So the dashed rectangle actually says that this aggregate relationship enrolled is going to refer the relationship gives, the only relationship inside this dashed rectangle. That's why if you have a dashed rectangle, there should be only one relationship in that rectangle. So in this case, it's gives. Gives is connected to teacher and course entities. But remember, we decided to merge these two tables together. So actually, enrolled should be referring to the gives relationship, but the gives relationship is contained inside the table called course. So since we merged them, we are going to refer to that merged new table. So these two are for teacher and student with advisor. These are the same tables. And remember, we decided to implement this gives and course tables by merging them. So since we merge, because of this one-to-many and total participation on the non-repeating side setting, we were able to merge them. Since we have merged these, now the enrolled relationship should refer to the table that contains this gives relationship. And since we merged gives with course, now the gives relationship is inside the course table. So therefore, for the aggregate relationship called enrolled, I'm going to store some foreign key for the primary key of the course table, and that's course code only. So in here I need a course code, and since this aggregate relationship is also connected to a student, I need to have some reference to the primary key of the student, which is SID. And I have also this additional attribute called grade that's also here. And so the foreign keys are described here. Course code is going to refer to the course table, and SID is going to be referring to the SID in student with advisor table. And since this is a many-to-many relationship, the primary key is going to be the combination of all its foreign keys. So this is an example where we merge the relationship with the entity set inside the dashed rectangle. But most of the time that's not the case. So therefore we also have an example for an aggregate relationship in the case that we do not merge anything inside the dashed rectangle. So for this setting, we have the entities A, B, C, and their respective primary keys are K, X, and U. And we have, so for example, for A, B, and C entity sets, these are our relational schema with their primary keys. And there is this existing relationship called R between A and B. It's a many-to-many relationship. And for R, we also need to store this additional attribute F. So for R, I need a foreign key that is going to refer to the primary key of A, which is K. So I have K inside R. And similarly, to refer to an entry in table B, I need a foreign key that is going to refer to the primary key of this table B. So we decided to have the same names. So in the R table, I keep K and X. K is a foreign key that refers to A's primary key, and X is a foreign key that refers to the primary key of B. Since this is a many-to-many relationship, the primary key is going to be k and x together, and f is just some other attribute. So since these are not named, we did not write the data type of these attributes. Then I would like to have an aggregate relationship AR, and for this AR relationship, one side is going to be connected to the table C, and the other side is going to be connected to the relationship R. So what is the primary key of R? It's k and x together. So I need to store these foreign keys for k and x, and together they are going to refer to an entry in table R using this primary key together. So for k and x, the foreign key is going to refer as a tuple to the primary key of the table R. And for this other side, I need to keep a foreign key that is going to refer to the C's primary key, which is U. So I store a U in this table AR. And for this U, it is going to be a foreign key referencing the U in C. So for this aggregate relationship, since it is many-to-many, my primary key is going to be the combination of all the foreign keys. And we also have this additional attribute M here. So for aggregate relationships, the important thing is that for the aggregate relationship to refer to the relationship inside the dashed rectangle. So we are not referring to A and B directly. We are actually just referring to R, the relationship, using the foreign keys together. And if you look at the ternary relationship, it is actually similar to the normal relationships. And one thing differs, that's the cardinality. And if it's many-to-many, actually for ternary relationship, if it's like many-to-many-to-many, then again the primary key is going to be the combination of all the foreign keys. For a different setting, let's say this is like one-to-many kind of setting for ternary relationships, then you just look at the values that you might insert to that table, and you choose the non-repeating one as your primary key. So in this case, for like one-to-many case, the non-repeating side is C, and you are going to just assign the foreign key that refers to C as your single primary key. For a different setting, for example, in this case, both C and B has non-repeating values. Again, this time, for one side, you are going to choose it as the foreign key that makes the primary key of your table. And for the other foreign key, you are going to say that this is going to contain only unique values. So this is actually very similar to what we have in normal relationships, but just the difference is how we read or how we set the primary keys and unique values is a little bit different. So we have two equivalent alternatives where you assign one side as unique and for the other one you make it the primary key. And like if this was also containing an arrow, then you are going to choose one attribute as the primary key, and for the other remaining two foreign keys you are going to say unique, for example. So we described the formal way of writing this relational schema, and for the next stage, for the design stage number 2, you are going to write the relational schemas, and you are going to also fix your ER diagrams if there are like any mistakes, etc. But we also have a shortcut notation of showing the relational schema. And in the homeworks, for example, or in the exams, you might see such notation, or we might ask you to write such notation. In this case, you just write the table's name followed by the attributes, and the foreign key is underlined. So if multiple attributes are the foreign key, you underline each of these attributes together, and then you write the foreign keys and the attributes and the tables that they are referring to. So now we are going to look at the relational schema for the ER diagram from lab number 1. So this is actually also on the website. So this is the relational schema example here. And following this relational schema example, we are going to start creating our tables. So in the design stage number 2, we expect such document that contains the relational schema of your tables, and we are going to use SQL-lit databases, and you can use the create table commands to create a database, create a SQL-lit database, but we are going to use this Escalate Studio. But let's give a 10 minutes break first, and we will continue at 2:30. If you have any questions, problems you might ask. Okay, any questions, problems before we start? So on the lab homepage, we have the link for Escalate Studio. And if you open that, it's a software to create tables for your database. You can also populate your tables using this application. You can also run SQL queries on that database. So we are using Escalate this term. Previously, we were using Microsoft Access, but that's no longer offered by the university for free. Then, like last term, we tried LibreOffice Base, which is kind of similar to Microsoft Access, but some of the error messages there were problematic, and LibreOffice Base uses the basic language, and since you get courses for Python, we decided to have something that's Python compatible. And SQLite, you can manage SQLite databases using Python, and SQLite is like an alternative of SQL. So there are like different versions, MySQL, etc. And this is one of them which is compatible with Python. And you can create this SQL database through Python commands. You can use create table commands to create a database, create tables to populate your tables. In the application side, we are already going to use Python. But to create the tables using some other software, more visual one, is a better option, because then instead of writing these create table commands, you can just visually design your attributes, design your foreign keys, etc. So Escalate Studio is one free option to do that. There are actually like different alternatives to create SQLite databases as well. So we decided to use this one. And like on the web page, if you go through Escalate Studio, you have this download option. I guess that downloads the version that's compatible with your operating system. And under this download page as well, if you need to like download it for a different system, you can get those download links for like the major operating systems. So then when you download it, it is going to be this zip file. You need to extract that. And without any need for installation, you will be able to run this program. So if you get any error messages, like you can write them to me to solve the problem, but without any requirements, it should run on the operating systems there. And this is a program to create databases, to create SQLite databases in specific. And if we have the relational schema description of our database, we can just follow these specifications that we design and create the tables for our database. So from the ER diagram, we created the relational schema, and using this schema, we can directly create our tables. So this is like a mid step. We give more information about the data types here, and since both entities and relationships are going to be defined as tables, we have this distinction through the foreign keys, and through how we set the primary keys of the relationships, we can enforce cardinality and participation constraints. And if we have these descriptions, we can like directly go here and start creating our tables, and that's what we are going to do today. So when you open Escalate Studio, you have this menu to create or add a new database. So actually, since our labs are recorded, what I would suggest is to first listen and like learn how to use this program, and in your own time you can like download it and use it, and you will have the recording to follow if you need to check. And if you encounter any problems, In the other lab, in the next lab, you can ask them to me. So that would be what I would suggest, because trying to follow while during this lecture or tutorial could be harder. So if you miss some part, you might be lost. So instead, let's first listen, I guess, then try to replicate it on your computers in a free time. Could be better. So under the database option, I have the option to add a new database. So this opens up this window, and in here, the database type that we are going to use are going to be SQL Literary. By default, it is chosen. For the file, I can choose to create a new database file, or I can import an existing database file. So for the project, for example, on one of your computer, you can create the database, and then to share that database, it's going to be just single file. And in the website, actually, we have this finished version of this database for this example. You can download this one and open it up. So for now, we are going to create a new one. So I'm going to click on this plus option. Let's keep on the desktop and let's call it example. The extension is going to be .db. So you need to, I guess, write it here. Otherwise, when you are trying to open the database, you might need to choose show all files. Otherwise, it is going to show only the ones with the correct extension. So this is going to be our example database. I'm going to save this. So this name is how it appears inside the program. It can be the same. You might write a different name for that as well. This permanent option is going to keep the database connected, so it's going to keep this configuration. If you are going to use this same database on like other starts, whenever you like open this program again, if you are going to need this database, the permanent option will be enabled. So I'm going to click on OK. So this is the example database. If I double click on it, it will connect to that database. So I might have lots of different databases here. So this is the unconnect option, disconnect option, and like at a time I will be connected to one of them, and while I'm connected to that database, I can manage the tables, create new data, run SQL queries, etc. So then I would like to start creating my tables, and I will follow this relational schema example. It's following the ER diagram from number 1. So let me keep this also open here. And in Escalate Studio, I would like to create a new table. And to create a new table, while this connected database is selected, I have this create a table option. Or under the structure menu, you also have this create a table option. When you select that, it is going to come up with this window, and I have the option to give a table name. And for this table, it is going to be called the user table. So I'm going to write user here. And with table names and attribute names, any of your naming conventions, you should not use any empty spaces. So while creating, it might allow to use empty spaces, but in later stages it might cause some problems. So with any of the naming conventions, it is better to leave no empty spaces. So if you need to write different words, for example, you can have underlined characters, you might start the next word with the uppercase without any space, etc. But using no empty spaces will be the better option. And then for the user table, I need to add some attributes. So I need the ID, name, surname, and password attributes. For this design table, so right now I'm designing the table, there is this button to add a column. So attributes are referred to as columns in this software. So I'm going to click on that. And for this attribute, I can specify the column name. So it is going to be the ID, my first attribute. And for the data type, I have a bunch of options. So the types that we included in the slide would be enough for you. So those are the main types, the numeric, text, date, and Boolean types. For example, in here you have like special types for numeric values, integers, doubles, etc. The difference comes from there, but a small subset of it will be enough for our usage. So for ID, it's going to be numeric. And one thing about SQLite databases, it doesn't check the type automatically. So while you are writing some values for that database or for that table, SQLite doesn't make a type check. So that's one little difference. In some other databases, for example in MySQL, etc., it might check for the type correctness. So whenever you enter something, SQLite will not check the type. So that's just one difference that you should be aware of it. But we might decide to convert this database into some other format later on. Therefore, writing the data type is going to be a good idea. And also if we are using some other database formats, for example, then that might be type checking. So writing the type is a good idea. So this ID is going to be the primary key of this table. So it's indicated here. So for any column, I can have different constraints. So if you choose the primary key here, then that is going to assign this attribute as the single primary key of this current table that I'm designing. So I also have this not null specified next to ID. So I also have this not null constraint here. So I'm going to check it as well. Then I'm going to click on OK. So if I would like to go back to editing this ID attribute, I can double click on its name. So I might change the settings and then click on OK. But this is the attribute's name followed by its type. And for some of these constraints, if it is the primary key, it shows this key symbol. If it has to have not null values, it shows this symbol. So let me add another attribute. So I'm going to choose this add column option. And then for this one, it is going to be called name. It's going to contain text values. And other than that, we don't have any other constraints. But remember, since we have chosen ID as the single primary key of this table, I can no longer enable the primary key option for this new attribute. So that's one thing to be careful about. And if we need to specify a composite primary key, that will be done using a different option. We will see that in a minute. But for name, I don't have any other conditions. So name can be null as well. So I'm not choosing any of these and I will click on OK. So I will add another column for surname. It's going to contain a text and that's all for this one as well. I'm going to create another attribute called password, and password is going to contain not null values. So I'm going to enable this option and click on OK. So far we are designing this table. We did not commit the changes for this table. So this table is not created yet. So under this example database, under tables, nothing is listed. So to commit the changes, there's this green button. It says commit structure changes. If this is a new table, it will create that table, create the attributes for it. So I'm going to click on this commit button. And it is also going to show the create table statement. So it says that, okay, you are about to execute this query. You can also check the query for correctness. Maybe while designing you did some mistake, you might also realize that mistakes here, for example. And it's basically saying what we designed so far. ID is a numeric primary key. It contains not null values. Name, surname, and password attributes are in this table as well. And if I click on OK, then it will execute this query on my database. It says committed changes for table user successfully underneath in the status bar. And if you check in the example database under tables, I have my user table, and if you also unhide these other elements, you see the columns for this user table. So that's creating just one of the tables. You also have this data part. You can populate your data base, we are going to see, but it's a better idea to first create all of your tables and then start populating the tables. So we are going to enter some example data in our tables. And before doing that, it's a better idea to create all the tables to be able to check whether we did any mistakes or not. Because while designing the tables, so for example, I created the user table first, and then I need to create a teacher table. The creation order is also important, because in the teacher table, I need to define a foreign key that is going to refer to the primary key of the user table. For this to happen, the user table should exist in the first place. So I committed the changes for the user table. Now I would like to create a new table. So while this example database is selected, because I might have multiple databases here, so I should be connected to one of them. I am connected to the example database. I would like to add a new table, create a new table here. And for this table, again, these are similar, but for a different table. I give the table name, it's going to be the teacher table. And
Hocam,
I
can
need...
I ask a question about
sure.
the user table? Hocam, why we can choose only one primary key? Because sometimes I think
So,
there are multiple primary.
while designing the attribute, if you choose this option, it is to assign one primary key. To assign a composite one, we are going to see how to do it, but we are going to use this other button for adding a table primary key. Then in here you can choose multiple attributes as the primary key.
Okay, hocam,
So
thank you.
it's just the way to create it is different. If it is a single primary key, you can just select it while creating that attribute.
Okay, hocam, I understand. Thank you.
No problem. So maybe it's also a good idea to show that how we can change our table. So if you just double click on any of your existing tables, you can go back to editing that table. Then if I made some changes, I have the option to roll back structure changes. So it says that don't commit these changes, or if I would like to apply these changes, I need to click on commit changes. So you might like change some of these things, but if you don't commit the changes, it's not applied. So if I close this table or window, it says that, okay, you have some uncommitted changes for the user table in the example database. Would you like to commit them, or would you like to close it? So right now we don't want to apply those changes, so I just close that window. So in here we were creating the teacher table. I'm going to add a new attribute for it, and in our relational schema we said that we need to keep a TID attribute here. It is going to be numeric data type. It's going to contain not null values. It is the single primary key of this table, so I can choose this primary key option in this attribute settings. Furthermore, it is a foreign key, so I also have this foreign key constraint here. I'm going to enable the foreign key option, but since foreign keys are referring to different tables, I need to configure it as well. So without configuring it, it will not allow to make it a foreign key. You see this little red symbol there. Therefore, I'm going to click on the configure option. So remember, foreign keys are going to refer to some existing different tables. And under here, foreign table is going to be the user table. For the teacher table, I cannot choose the same table as my foreign table. This should be a different table. And the changes should be committed. So while creating the user table, while designing it, remember, if you don't see any table under here, you need to first commit the changes for that table. So that might be the reason why your table is not there, but in our case, user table is here. So I'm going to choose user as the foreign table. And for the foreign column, it is going to be the primary key of this table. So since we most of the time put the primary key as the first attribute, it's here already, but it's not selected because it's the primary key. It's by default selected because it was the first attribute here. And I need to choose the one that's the primary key. And there are these reactions for on update and on delete options. So if we would like to keep the integrity of the database, we are going to choose the cascade option for both of these. And what it does is, let's say I have users number 1, 2, 3, 4, etc. And for the users that I would like to assign as teachers, I'm going to include their IDs in the teacher table. So for example, I write 3 in the teacher table. At some time, if I were to delete the user with ID 3 in the user table, if onDelete cascade is selected, it will also delete the corresponding 3 in the teacher table. So otherwise, if I just delete the 3 from the user table, but if 3 stays in the teacher table, then this 3 in the teacher table does not make sense because there is no corresponding such user. So enabling the onDelete cascade option is going to be what we are going to do. And onUpdate is a similar thing. It functions when we are updating. For example, for a user number 2, if I would like to update the user's ID to 7, it will also find the related entry in the teacher table. It will find the 2 here and it will update it to the 7. So these two are helping us to keep the integrity of the database. We also have some other options. So this Escalate Studio is a complicated software actually. You can do many things, but we are going to be interested in only a small subset of it. But these like matching options and deferred foreign keys, they are kind of doing like whenever you compare different things in these different tables, it's according to like whether you apply the changes immediately, etc. So these options, we are not going to be interested in them. But for the foreign keys, we are going to only set for onUpdate and onDelete. We are going to choose the cascade option to do what I have told. For other options, it might set the value to null, for example. That's not that useful. So cascade option is going to be what we are selecting. So I'm going to apply this configuration. Then it's the foreign key now. So I'm going to click on OK. So for the teacher table, I only have the TID attribute. It's a numeric type. It is the primary key, single primary key of this table. It is a foreign key. So if I double click on the attributes, if I need to check the foreign key settings, I need to go to this configure option. So my foreign table is user table, and in there it is going to refer to this ID attribute. And it contains not null values. Again, I need to commit the changes first. So I'm going to click on this green button. It shows me the SQL query for creating this table. You also have the option to don't display this as well, but like you can keep it to see underneath what SQL commands are executed. And it says there is no error. It's committed the changes. And now under my example database, under tables, I can also see the teacher table. So for all my tables, I'm going to do a similar thing. So I'm going to create a new table, this time for the student with advisor. So that's the name that I'm writing here. I need some attributes here. So I'm going to create a new one. This is going to be the SID. SID will contain numeric values. It will contain not null values, and it is the single primary key of this table. Therefore, I can choose the primary key option directly from here. Furthermore, it's a foreign key to the ID of the user table. So I will enable foreign key and configure it. The foreign table is going to be the user table, and the foreign column, the matching attribute in the user table, is going to be ID. And remember, for our reactions, we choose cascade for onUpdate and onDelete. I will apply this, click on OK. That's our attribute. And for the student with advisor, we also have this scholarship attribute. So I'm going to create a new attribute. It's going to be called scholarship. It will contain numeric values. And other than that, that's it for this attribute. I need another one. This is going to be advisor TID. It will contain numeric values. It will have the not null constraint. Furthermore, it's a foreign key. to the teacher's TID. So I will choose foreign key, and under configuration it's going to refer to the teacher table because this user should be a teacher in order to be the advisor of this student. So in the teacher table, the only primary key is TID, and I will also choose cascade for on update and on delete, and I will click on apply, click on OK. My attributes are here, therefore I can commit the changes, and these are the changes that I will do. I will click on OK. So let's continue with the send table. So right now you might see that the create table option is not enabled. That's because we just created the table. The database that I would like to add the table should be selected. So that's why the create table option was not enabled. So now I can choose to create a new table. So if it is at some point not enabled, you need to choose the database, because there could be like multiple databases that you can create a table in it. So this is going to be called as send, and I will add some attributes here. This is going to be the sender ID. It will contain numeric values. It will contain not null values, but this time the primary key is a composite one. So I need all three of these, sender ID, receiver ID, and date, to find a unique row in this table. So I'm not going to choose the primary key constraint for this single attribute this time. I will use a different option. But for the foreign key, again, this by itself is going to refer to the user's ID. So I'm going to choose this is a foreign key. I will configure it. This should be an existing user, and the primary key for a user is ID. Again, I will choose the cascade option for update and delete. The difference is that I'm not choosing the primary key option for this specific attribute, because this by itself is not the primary key. Primary key is a composite one. More than one attribute is the primary key. Therefore, for now, I'm leaving this primary key option as empty. I will add the other attribute, which is called receiver ID. It's going to be a numeric data type. It will contain not null values. It's a foreign key to the user table again. So I will enable the foreign key option. I will configure it as for the foreign table, it's going to be the user table. My foreign column, the matching attribute is ID, and for update and delete options, I will choose the cascade. I will apply and click on OK. I also need the message attribute. It's going to contain a text type, and other than that, we don't have any other constraints for this attribute. I will create the last one. It's called date, if I can write. And for this one, the type is going to be date. It contains not null values, and I will click on OK. And these are my attributes. I need to specify the primary key, which is composed of multiple attributes. So to assign a table primary key, we are going to use this button here. So I can add a table primary key. It's going to be the combination of multiple attributes. In this case, it's sender ID, receiver ID, and date together. And this collocation part is, again, not going to be in our interest. It is specifying how we sort these data. So usually if there is only one primary key, we can sort according to the primary key. But while sorting, if we have multiple columns as the primary key, this is actually to define an order to sort the data as together. But we are again not really interested in sorting this collocation part. We just assign which attributes are the primary key. So I'm going to click on create. The table primary keys will be shown in this part. Other than that, we can also have table foreign keys. So while if an attribute by itself is the foreign key, we specify it while creating those attributes. But if multiple things are going to refer to multiple things in a different table, then we are using this add table foreign key option. So for this table it's not required, we don't have a composite foreign key, but if you need to do that, that's the way to do it. So you can have like from this column, from this table, I have these foreign keys. At the same time, they are going to refer to some matching attributes in a different table. In that case, that's how we design it. But for this table, that's not the case. So that's it for this table. I'm going to commit the changes and I see a summary of this create table statements. If I click on OK, it says we created successfully. Now I'm going to create another table for the course. In here, I need the course code attribute. It's going to contain numeric values and it will be not null, and it's the single primary key of this table. Therefore, I'm going to choose the primary key option from here. So I will have another attribute. It's the description. It contains a text, and that's it for this attribute. I also store the instructor TID. Remember, we merged the course and gives tables together. Therefore, we store this foreign key instructor TID in the course table. It will contain numeric data because the TID of teacher is numeric, and it will contain not null values to satisfy the total participation constraint. You have to find an instructor teacher to create a new course. And then this instructor TID is going to be a foreign key that's going to reference the teacher table, and in the teacher table the primary key is TID, and I would like to enable the cascade option for update and delete reactions. So that's it for this attribute as well. And then I will commit the changes for this table. So I see the course table listed here as well. Now for the weak entity, I'm going to create another table. Will be called has medical reports. I need this date, which will contain date type of entries. It will be not null. But since the primary key is a composite one, I'm going to use the other option. First, I need to create all the attributes. So I need a description, which will contain text. I need another attribute called SID. This will contain numeric values, and this will be connected to the student table. So it is a foreign key. And the foreign table is, in this case, student with advisor, and in that table the primary key is SID, and on update and delete we are going to cascade, and for this table SID is going to contain not null values, so that's also selected. And for this table I will assign this table primary key, and date and SID together is going to be the primary key for this table. So then I will commit the changes. And we also have our last table called enrolled, so I will create another table for that. Enrolled, and I need the course code here, which will be a numeric type. It will contain not null values, and course code is a foreign key to the course table for this enrolled table. It's going to be a foreign key. The foreign table is going to be the course table, and the foreign column, the matching attribute, is going to be again with the same name, course code. So the naming conventions, sometimes for foreign keys we are using the same name. It could be the different name as well. The important thing is for this attribute, what is the foreign table and what is the foreign column. But for simplicity, we sometimes use the same name for the foreign key with the primary key of the other table. So for this table, course code is like this. I will add another attribute called SID. It's going to contain numeric values, and it's going to be not null, and since it's a foreign key, I need to set it as well. So to the student with advisor, to SID in that table, and I will enable the cascade options. And we also have a grade attribute here. It's going to contain numeric values, and that's it for this one. And for the primary key, since it's a composite one, I choose the add table primary key option, and it's the combination of course code and SID together. So I will create and commit the changes. I see the SQL code for it. Whenever I click on OK, it says that committed changes for this table successfully. So I created all my tables. And in fact, if you like enlarge this window, the design windows that we were using for each of these tables are not closed when we commit the changes. So whenever we choose to create a new table, a new window comes up. So you might see this like enlarge options, close options for the window that's inside the main window. And in here, there are actually some options to tile these windows. If you choose that option, you will see that each of these tables design windows are still open. So like whenever you want to go back to one of the other tables design, you can just double click on that table. So we can also like close these designs also. And like if there are some uncommitted changes in one of the tables, that will say that okay, you have some uncommitted changes, you might want to check, etc. But let's start adding some data into our tables. For example, in the user table, the user table is a good starting point, because let's say if I would like to go into the teacher table and add some data, in the teacher table I just have this TID attribute. So going into any of these tables, so we were looking at the structure view. If you go into the data tab, then you can create some data, you can populate this table. But if I want to add some data here, that TID should refer to an existing user. So in order to add some teacher, that corresponding user should exist first. So that's why starting from a parent entity is a better way to start populating the database. So in this user table, I'm going into the data tab. I would like to create or insert a new row here. I'm going to click on this plus sign. Then I need to give an ID for this new user, a name, a surname, and a password, for example. Then to add another user, I have this plus sign again. To insert different rows, which position you insert, you can choose it using this triangle. So I chose to insert this new row below the selected row. So I will choose that one. I can add some other user. For example, let's don't give any name to that user, but let's give some password for this user. Let's add another user, maybe Aisha. But any of these changes are not yet committed to our table. So the blue outline says that. Because we have the blue outline, it says that, okay, you are inserting something here. So I can have null values all, for example. These blue lines say that there are some uncommitted changes to the database. And if I were to like close this window, then these are not applied, these are not done in my database. I need to commit these changes. If I click on this commit option, for some of them I have a problem. So under the status part, for the blue ones I don't have a problem, but they are not committed, because for the group here, for these new entries, there were some problems, and because of that these are doable. But since these failed, we have not committed any of these changes. So that's what it means. So the error messages for the user's password, so for some of the entries, the user's password failed the not null constraint. I cannot have a user without a password. So that's what it's saying. So let me write something as a password. I'm clicking on the commit button. For this user number 3, that's okay as well. But for these users, the ID is empty now. So these two are my new error messages. I cannot leave the ID empty. For example, I might say that, okay, let's delete these rows. So I'm about to delete the row 4. And let me also delete this row, the other row. So now if I click on the commit changes, now everything is applied to my database because I don't see any blue outline here. So for example, for some of the users, if I decided to change things, I might go there, change some of the values, and for those values that we change, there will be the blue outline, meaning that there are some uncommitted changes. And whenever I click on the commit button, it will apply those changes. Then whenever I go into a related table, for example, to the teacher table, if I would like to insert something here, if I click on this plus sign, for example, if I write 6 here, I will not be able to keep the 6 if I try to go out of that row. If I double click on there, so it automatically replaced it with 1 because the user with ID number 1 is the first user. If I double click on here and click on this triangle, it will show me the existing users. So because of this foreign key constraint, to be able to add a teacher, that teacher should be an existing user. So these are the existing users with their IDs and the other settings. So in here it says TID because it is going to replace the TID in this teacher table. But these other attributes are the ones that are included in the user table. For example, I can assign Jane as a teacher, for example, and for the other one, let's assign Ayşe as a teacher as well. And these changes are not yet committed. If I click on the commit changes, it will commit those changes. Let's say I would like to add another entry in the teacher table. Let's say Ayşe again. If I click on the commit changes, this time it says that unique constraint failed for teacher TID. So teacher's TID, since it's the primary key, it should contain unique values. But this new entry that I would like to add does not follow that rule. So I need to change it to something else, or I can click on this unroll rollback option as well. So any of the blue and red outlines will be disappearing, or I can say, okay, let's delete this row as well. Let's roll back in this case. So that's actually how we can populate the database. And if you go to the website, there is this finished SQL database for this lab. If you download it, it will be a file with lab2.db name. So that's here, lab2.db. Let's say I would like to open this file, the one that I downloaded. So under database, I'm going to add a new database, add a database option. And this time I would like to browse for an existing database on the computer. So I will find that downloaded file, lab2.db. So the extension is important since we would like to be able to find this file easily. If you omit the extension, you can say all files, show all files, and from here you can find that file. It will open it. The extension is just for finding it easier. So this time it will be called lab2. If I click on OK, this is some other database that I can connect to. So if I double click on lab2, I will be connected to this database as well. And here are my tables. So this has the same setting, but for the tables, this contains some additional example data in it. So if I go into the user table, for example, I can see the users. If I go to the teacher table, if I choose the data option, I see that users from 1 to 5 are assigned as teachers, for example. If I check the student with advisor table, I see that users from ID 6 to 12 are assigned as students. Some of these students have scholarship. But for all of the students, I need to assign some advisor. So let me say that I would like to create a new user in this table. So at any position you can add it. Let me choose the last one. Let me click on plus sign. I'm going to create a new student. I have the password. I don't need to write the surname, right? Surname does not contain the not null constraint. I can commit these changes, but let's say if I were to forget to commit the changes, if I go into the student table, if I try to add a new student, so Sinan is not there, the student with ID 13 is not there, because if I go back to my user table, this is not yet committed. So sorry, user table, this is not yet committed because of this blue outline. If I were to close this table, it will say that there is uncommitted data. So let me not close it. Let me first commit these changes, and then in the student with advisor table, if I come here for the SID of the student, I can choose 13. And let's write some scholarship amount, and let me try to commit this, but I'm not able to, because for this advisor TID, I need to select something. It should be not null. And I cannot just enter a random value here, because it's a foreign key. I need to double click on the cell, and from this triangle, I can choose an existing teacher's ID. Or if I were to just know and directly write an existing teacher's TID, that will be also fine. Then I can commit these changes. So I now have a new student, but for that student I had to assign the advisor as well. So because this was a constraint from the design of the table. So for the other ones, for example, in the course table we have a bunch of courses. And in the enrolled table, if you check the data, some students are enrolled to some courses. For a course, there are multiple students. And for the same student, for example, the student with SID 6, that student is enrolled into multiple classes. For this table, course code and SID together was the primary key. And because of that, I can insert data that's many to many. But if I try to insert the same tuple, so for example for English 101 there is SID 6 matching. If I try to insert the same thing again, this time it will say that okay, this time the unique constraint is failing for course code and SID together. Because course code and SID together is the primary key of the table, it should contain unique values as a tuple. So let me delete this row. If I check the send table, in here I have some messages, for example, between sender and receivers 1 and 2, or let me check this one. So 8 sends to user 11 on this date, and 8 sends to user 11 on a different date, for example. And this is how we write the dates as a string. So the year followed by the month followed by the day. And this contains the message. For example, if the same user, user number 8, is going to send a message to user number 11, then this should happen on a different date. So for example, if I write the same date, then it does not contain a unique value. So for these 3 attributes together, it is not a unique value. But if I were to change the date on a different date, this same user could send a message to the same receiver. So that's no problem. Again, in here, we are using the grid view to add the data, add some entries, but there is also the form view, which is, some people might see it more complicated. It makes the things crowded. But for example, for the dates, you can choose the date directly from here. And we have total 6 rows, and this is row 6 for now. I can go to different rows, for example, and these are showing the values in those fields, in those attributes. So that is going to be a way of populating the database. And then for the next tab, we have under the tools, we have this Sql Editor. And in here we can write SQL queries to run on our database. For example, most simple one would be to select star, to select everything from the table called user. And in here, the good thing is that if you use Control and Space buttons on your keyboard, it has the autocomplete option. So any existing table, any keyword, it will autocomplete. And if you run this query, for example, you will see the values here. And one last thing to show. So we had some courses and people were enrolled to those courses. If I go to the course table and, for example, if I were to remove English 101 here, then again I need to commit these changes. And if I go back into the enrolled table, right now, since these tables stay open, it is showing up the last version. I also need to like refresh the table's data. If I were to refresh it, since we said that on delete cascade, it deleted the related entries in the enrolled table as well. And if I go back to my course table, for example, if I were to change the course code of Math 101 to Math 102, if I commit these changes, if I go into the enrolled table and refresh the data, I will see that it is also updated here. So the cascade options are doing that. And that's it for this lab. Any questions, any problems? What I would suggest is to like replicate this on your own devices as well. Try to like play with it, play with the data, see what errors you get. So this is going to be what you will do in the implementation stage 1. So a later stage of the project. Any questions, problems?
Hocam, I have a question. Hocam, if we delete the all users' data, then there will be nothing about the exam.
Yes.
Right?
So
Okay.
most of the things will be gone, and that's something that you should be careful. If you delete and commit, there is no like a simple undo option. So you might so whenever I refresh these, I see that lots of things are gone, and there is no like a simple undo option. So deleting from the database is kind of risky.
Okay, hocam, I understand. And hocam, can I ask something about the project stage 1? Hocam, should we use is a hierarchy in the Dravio, in the diagram?
Well,
Because it's very complex, we prefer to not use, but
well,
this lesson.
For some parts you might need to use it, but for the specific description, maybe you can send an email so that I can like answer for that specific example. But you don't like have to use it. But for most of the descriptions, in some place using it was like a good idea.
Okay, hocam. Because it's a complicated diagram, we don't prefer to use but. Yani siz burada kullanmışsınız, o yüzden acaba kullanmamız gerekir mi diye.
Yok, zorunda değilsiniz ama mail gönder de bir hani bakayım o spesifik örnek için hani.
Olur hocam.
Olur.
Teşekkür ederim.
Any other questions, problems? So next week we don't have a lab. The other week we are going to have lab number 3. So see you later then.
See you hocam. Teşekkür ederiz.
Önemli değil. Görüşürüz.